Hello and welcome to lecture number 9. In this lecture, we will discuss SAM matrix. And by SAM matrix here, we mean the key indicators that when you measure, you can know if the SAM program in your organization is a proactive program or a poor program. You can't manage what you don't know, but plenty of organizations implement a software asset management and license optimization program without any structured way to measure actual outcomes. This lecture seeks to provide some ideas on how to measure and track data, operations, and outcomes from a program focused on optimizing the value of usage of software in an organization. Business cases for a software asset management and license optimization program will present broad ideals of what success looks like, such as reduce risk of unplanned payments from using unlicensed software, reduce risk of security breaches arising from use of unpatched software, save money on unneeded maintenance, avoid over-purchasing of software licenses, reduce the time and effort required to fulfill requests for new software. Crossing the gap from high-level objectives like these to identifying how to actually measure outcomes can take some thought. The key principle to apply here is to work out what's meaningful and important, and seek ways to measure those things. Best-in-class organizations have a robust approach to monitoring and improving a range of metrics. Metrics will often be used as the basis for key performance indicators, KPIs, for teams who have responsibility for managing and influencing those metrics. With that in mind, some sample metrics that may be useful to help with software license optimization are listed below. The metrics have been broken down into three areas: input data metrics, operational metrics, and financial metrics. First, we discuss input data metrics. A software asset program heavily relies upon comprehensive and accurate input data about IT hardware and software assets within the organization. This data is best held within a central asset management database, AMDB, containing all of the data gathered from multiple sources. Input data focused metrics are useful for assessing the trustworthiness of this asset data. They can be used to highlight areas where data may not be clean and to help identify data gaps for remediation. Examples are percentage of active devices for which current hardware and software inventory is available, percentage of devices found on the network which are not recognized as known assets, percentage of devices found active on the network which have a status indicating they should not be active. For example, they are classified as being in storage or retired. Percentage of devices found on the network with a bad, blank, duplicate, or blacklisted serial number. Percentage of all IT assets in the organization that are represented in the AMDB or the Central Asset Management Database. Number of IT asset purchases that are not yet presented in the AMDB. Percentage of asset with no recorded location, business unit, etc. Percentage of computer records with missing processor information. Auto discovery tools which gather inventory don't always reliably collect this data. Number of active individual use assets with no assigned user. Number of assets which are assigned to people who have left the organization. Percentage of virtual machines for which physical host information is not known. Second, operational metrics. Operational metrics help to measure the operational performance of SAM activities. Examples are percentage of application installations that have been mapped to normalized application details, number of installations of commercial applications without license, percentage of application installations which have not been used within the last, say, 90 days, average number of different versions deployed of each application, percentage of assets which are not actively deployed, for example, hardware assets on the shelf or software licenses not used, percentage of installations which are not using the latest patch level available from the software publisher, number of installations of applications with known security vulnerabilities, number of installations of applications which are unauthorized or prohibited for use, percentage of installations which are of applications that have reached their end of support life, average time taken to fulfill an end user's request for new software. Third type of metrics is financial metrics. Financial metrics are useful for measuring the outcomes from a SAM program in terms of the value or cost to the organization. Examples are value of software installations proactively removed, value of maintenance not renewed, value of software requests fulfilled from existing software license entitlements, for example, without having to purchase new licenses, value of unlicensed deployments identified and remediated, percentage of software licenses under maintenance which are currently used, value of contingency on the company's balance sheet or allocated in budgets for unplanned software license liabilities, for example, due to software audit true-up fees, number of software vendor audit notifications received per year, labor costs associated with responding to software license audits and or average cost per audit, costs paid arising from software license audit findings per year, number of security incidents arising from software vulnerabilities per quarter, percentage of license and maintenance costs that are charged back to other parts of the business, ratio of the value delivered to the organization from the SAM program to the full-time equivalent people supporting the program. And these were the three main sectors of metrics with the details of every type of metrics. And if we succeed to measure these metrics successfully, we will be able to measure the effectiveness of the SAM program, whether there is a SAM program or if the SAM program is completely absent. And if the SAM program exists, we can measure its effectiveness. Is it a proactive, effective SAM program, or is it a poor SAM program? Thank you very much for listening, and see you next lecture.